In the previous video, we learned how to solve linear inequalities algebraically. Now let's understand how to represent their solutions graphically and solve practical word problems based on inequalities. Graphical representation helps us visualize all possible solutions instead of simply writing them. We use a number line for this purpose. The first thing to remember is the difference between an open circle and a closed circle. An open circle means the boundary value is not included. This happens whenever the inequality uses the symbols less than or greater than. For example, if x is less than 3, then 3 itself is not a solution. So we draw an open circle at 3 and shade all the numbers towards the left. Similarly, if x is greater than 2, we draw an open circle at 2 and shade towards the right. Now consider x greater than or equal to 1. Here, 1 is included in the solution. So we draw a closed circle at 1 and shade everything towards the right. Likewise, if x is less than or equal to 5, we draw a closed circle at 5 and shade everything towards the left. This simple idea is enough to solve most graph-based questions. Now let's solve an example. Consider the inequality 7x plus 3 is less than 5x plus 9. Subtract 5x from both sides. We get 2x plus 3 is less than 9. Next, subtract 3 from both sides. This gives 2x is less than 6. Finally, divide both sides by 2. Since 2 is positive, the sign remains unchanged and we get x is less than 3. On the number line, draw an open circle at 3 and shade everything towards the left. Now consider another example. We have 3x minus 4 divided by 2 greater than or equal to x plus 1 divided by 4 minus 1. First, simplify the right side by writing minus 1 as minus 4 divided by 4. This becomes x minus 3 divided by 4. Now, multiply both sides by 4. Since 4 is positive, the sign remains the same. We get 2 times 3x minus 4 greater than or equal to x minus 3. Expanding gives 6x minus 8 greater than or equal to x minus 3. Subtract x from both sides to obtain 5x minus 8 greater than or equal to minus 3. Add 8 to both sides and we get 5x greater than or equal to 5. Finally, divide by 5 to obtain x greater than or equal to 1. So we draw a closed circle at 1 and shade towards the right. Now let's solve a word problem. A student scores 62 marks in the first examination and 48 marks in the second examination. How many marks must the student score in the final examination to have an average of at least 60? Let the final marks be x. The average is 62 plus 48 plus x divided by 3. Since the average should be at least 60, we write the inequality 62 plus 48 plus x divided by 3 greater than or equal to 60. Multiplying by 3 gives 110 plus x greater than or equal to 180. Subtracting 110, we get x greater than or equal to 70. So the student must score at least 70 marks. With this, we've completed the chapter. Remember 3 important ideas. First, solve inequalities just like equations except when multiplying or dividing by a negative number. Second, use an open circle when the boundary is excluded and a closed circle when it is included. Finally, pay close attention to words like at least, at most, greater than, and less than while forming inequalities. Once these ideas are clear, solving inequality problems becomes quick, logical, and much easier in examinations.